Okay. Welcome back, everybody. I'm Sam. This is my dev stream for procedural generation using Apparance, which is a procedural systems plugin for Unreal and Unity that I've built, and I'm going to be showing you how it works over a series of streams, and this is the third one. I've found a nice asset pack on Fab for modular space station pieces, and we've been gradually building a procedural space station room and kind of seeing where it goes, really. Last time we tried to get I tried to showcase one of the sort of newer features of Apparance with the interactive in-world editing handles, but we hit a little snag, but it was a silly mistake, and we can go through the fix for that in a minute. So we'll do that. Hopefully the audio is better this week. It's been so difficult to measure and test. Twitch doesn't really have a way of telling me I'm too quiet, other than feedback from chat, but we'll see. The previous two streams have been uploaded to YouTube if you want to catch up, and this one I'll do the same with this one as well. Yeah, so let's get started. So if you remember, we have these procedural rooms, and you can change a bit bigger. You can change the size, and it will rebuild accordingly. I've got another one here, slightly smaller, and they also have a seed value, which is used to randomize a few things. Currently, just the window choice is randomized. And the feature I was showing you last time was this smart editing feature here, which if I turn on and then move that out of the way, it's just the editing panel. It doesn't get used for much right now, but that handles the interactions. And if we select this, we should have some handles. At the moment we've got an end handle, and I think it's on this end, and now they work. Yes, I think I may have saved it with the fix in place. The top handle was the move, that was working, but we started with the next thing we were doing was resize, which is these end handles. So if I open the procedure for this and dig into the editing, I can show you what the problem was. So in here we have, I think I might redo these because we didn't cover them. No, it's fine. So this is the handle, one on the east side, one on the west side. That's the part that the mouse interacts with. We've got a sub procedure here just to draw some visuals for that, which basically a transparent highlight whenever it's highlighted, and that's switched on here from this output of the handle. But the interaction is triggered via this drag input, and I've collected together two different things that happen at once. One is that one of the frame parameters for this is resized, but we also move the entity as well. I'll explain why in a minute. And this is for the other end, and it's basically the same. We'll do the two north-south sides. I'll build them from scratch so you can see how that works. But to show you the effect we were after, it means if you drag on one of these things, it will resize in that direction. Now it slides and jumps because it only supports whole divisions of room, but the reason we have both the size and the move is because if you just resize, it would size around the center. But I want these handles to work as just a single side. So as we are increasing the size, for example, we also need to move the actual actor itself. Otherwise, otherwise, if I turn that off for a minute, otherwise this center would no longer be in the center, because you can, as well as, if I manually change the parameters here, if I resize it, you can see it's sizing about the center. But if I didn't have the entity move, it would also move the origin, which is you would end up in situations where you get your actor location is not in the center, which is not ideal. And also it could end up outside the object, which is a bit messy. So we'll leave that there. And with this functionality, it does both for you. And on this end, similar effect. Drag to make that side further away from the center. So we've still got the move on top. We want the top and bottom handles as well. So we'll do them in a similar way. If I go in back to the procedure, we can see it's going to be very similar to this, but we'll build it out from scratch. This similarness is probably something that should probably be in a sub procedure, but we're not going to do that right now. Oops. So what I will do, we're going to need to. So I switched over to our 9 slice, which we're using for the walls, to do the same thing for these handles. A slightly bigger bounds, you can see it lies outside here, and it's quite a thick outside. So we're basically chopping a meter off to make a handle, and that's so you can select it from above. If it was, we could have it like flat, and it would be tricky to highlight from above. But there's no reason you can't do it from here and still be able to use it. Okay, and so that means, so we've used the west and the east, we've got both of those on either end. We want to do another handle, which I'll make a copy, but this time we're going to do the south side first. Each handle needs a unique name so that the interaction tracking works. We will do a very similar thing here. Pick up another output. There's no visuals on that, although there is technically a handle there. So we'll copy the highlight as well. Obviously that needs to connect to the south, and only if it's highlighted. There we go. That's now we now have a south handle. It doesn't do anything. Oh, hang on. Oh, it's still wired up to this one. So yeah, it doesn't do anything. Unlike these. When you duplicate, it tries to keep connections in case you are just parallel, redoing similar, but maybe then you can make changes. So we need to do the resize, which we will show. I'll show you just the resize on its own so you can see the problem that we're talking about. Oh, the fix for why it wasn't working last time. I had the name of the parameter that this was going to change. I named it after the input to this procedure. What you need to do is, it's the input to the top level procedure that's being built, which is over here, is called bounds. I had them named differently before. I've named them the same to help avoid that problem. But yes, because it was the name here and not the name at the top. The logic couldn't change this top level parameter. Where's our thing gone? Yeah, so this parameter here is what it's actually trying to edit. So it has to be that name and not some random procedure. Anyway, that was the problem. Let's go back in here. Yes, so that's why we have the parameter name here is bounds. It's the top level parameter you see here. The amount, now these two are going in the X direction, hence they're 1, whereas this time we want to go in the Y direction because we're going orthogonal. Everything else should be the same, and in theory that means we can drag that. Now here we go. This is if you did want it just to always resize around the center, then you can do this, and that could be your control. But actually, when building and adjusting and tweaking a level layout, I think it's more useful to be able to just tweak aside without really changing anything else. So we want to get that similar functionality and not have it stay centered. We need to move it as well, much like this move is doing. So it's the same operation as that. We can see the entity move for the XY move is here, and for the others we've got an entity move as well. I'm just going to copy that one. Now these inputs here, they use the generic list input type, but they have a specific structure they're expecting. And in this case it's whatever data this is spitting out. You just don't need to deal with it and process it in here. But this input supports either a single operation or a list of operations or actions. So, but to do that, we have to build these into a list, and that's done using this append operator here. So each value, hang on a second, each value can be appended. So this first one will add that value to an empty list, and then it will feed that into the next operator, and then it will append the next value, building up the list, and then this output will have both in it. So that gives us our drag and our move. We'll see what we can make sure that works out here. So we've got a drag and a move. Okay, it's moving it the wrong way. That's because we copied and pasted. So instead of going in the X, we want the Y. Now the next question is, does it go the right way? No, it goes the wrong way. A lot of this stuff is trial and error. I'm sure it's the same with any form of programming or scripting. There we go. So that's now moving the right way, much like these ones do. I mean, that's part of the beauty of it being also interactive, is you can see immediately and try and iterate on your values and your setup and your logic. Okay, so now the other end, I'm just going to duplicate this, rewire it to be the north side, change the name to north so it doesn't clash. Let's see if what that does by hooking it up here. So now we should have north side handle, which does exactly what the south side handle does. So we need, so the sizing is right because that's relative to the handle, which is facing outwards, but the move is not. So we need to flip this move from a negative to a positive. There we go. So now we can adjust, position, arrange our rooms. And if we click on this one, we can do the same for that. So these could be corridors or they could be rooms. You get to basically mess around with them as we see fit. That is a kind of, this is what I was trying to show last week as a sort of brief introduction to the smart editing functionality that is available in Apparance. Okay, so without wanting to spend too much more time on that, there's lots more we could add. I mean, there's things like rotation, if we wanted that, height, any parameters we could bring out as controls. So the these actions you can do on click and drag. Click would be, for example, if you had something you were toggling or a setting you were applying, and both these inputs can apply changes to the input parameters going into the procedure. So if we look at editing, it's an experimental feature, so I'll need to turn that on. So the box handle we've used, edit mode we've used. So we've used the entity move, we've used the frame size. There's an entity turn for doing rotation of the actual actor. There is, all right, these bottom ones here. So largely these set parameter, they are general parameter editing for any inputs you have on your procedure. So for example, this seed value, we could have some logic where if you click on a particular bit of a particular handle and you click on it, you could have it change the seed value, maybe it increases or decreases. Hey, we could show that, because in fact we could show that fairly easily. The top handle, at the moment there's different, you can have different behaviors for click and drag, and if you just click without drag you'll get one, and if you drag it won't do the click. So what we could do, let's for example bring in set parameter integer. I'm just going to stick it up here because we're just going to illustrate it. What we're changing is this seed, which is actually just called hash. Oops. Indexing won't be needed. Now the value, let's just hook it up and see what happens. If I hook that up to the click, it means if I click on here, seed value here has changed to 0, which is of limited use. But we can improve on that. You saw the windows change, so it's changed to the seed value 0. What we really want to do, as an example, this is just an example, perhaps is increase the value of the seed. Now to do that we need the current seed, which we need as an input, and we'll need to add 1 to it. So if I just drag in an add of 1, that'll be our new value, and we'll need it from outside. We need that information to come in. So I'll just call it seed, like the seed. Quite often use hash to designate seeds, just as a way of visually tagging them like that. We only have 1, so I'll just call it that. Now, if back here, I need to hook the current seed up. I'll put that back over there. Now, what's going to happen is, so currently it's 0, so that'll come in here. It'll add 1 when it's adding this handle, and then on the click it knows to do a set seed to 1, and then it'll rebuild it with a new input, and that'll now then bring in a 1, which will become 2, and it's sort of a iterative process. You're basically setting up instructions of what to do in certain situations based on the current state of your procedure. So that means now, in theory, as we click, the seed goes up. So you can see down here, we're now on 11. Every time I click, it goes up, and the windows change. So that will be an example of some click interaction. I've got test projects where this whole system is used quite extensively for example, spline editing, with handles and widgets and lots of menu options, and you can actually build kind of like semi 2D UI on your objects as well, and they can act like buttons, and you can have functionality on them, and it extends to things like adding item entries to lists, changing values buried inside lists. There's lots you can do with it, and you can build up quite powerful editing functionality. The town toy demo on itch that I've got was built using this functionality. Let me just find you a link. Hang on a second. How do I hide that? Right, I just wanted to hide that before I drag this across. So this is my town toy project. This was built using all of this handle editing functionality. You can get it on itch for free. Look up the Apparance Studios account. Yeah, and it's just a little toy to play with interactive editing and procedural content and object interactions as well. So the buildings interact with the ground, and adjust the properties, that sort of thing. Have a play with that. That's built as a standalone application as well. So all the editing functionality with handles and procedural interactions is all runtime as well. So this was a showcase of that. So have a check that out if you can, or if you're interested in this sort of functionality. So today I was going to go cover that, get that working again, show you how that actually was intended to work. So we've got some nice editing handles. I'm not going to spend any more time jazzing them up. They could be much prettier, I'm sure, but for now that'll do. We're sticking to rectangular things, and so rectangular alignment is fine. And the next thing I wanted to look at today is the floor. So as you can see at the moment, the floor is I'll turn off the smart editing. The floor is not quite aligned to the edge, and that's because it's fitting the floor to the whole bounds, so the outside, which means you can actually probably see that if you go in here, you can see it doesn't quite reach the edge because it's only done in a whole number of these 2x2 tiles. In fact, it's not even symmetrical in this case, because it's built from one side outwards. So there's something else I discovered with this asset pack, is that there is actually supposed to be a floor piece along here that brings these out to the same distance. So it's probably worth us putting that in. One, it'll tidy up this edge here, and two, it means the floor and the ceiling can use exactly the same logic and fitting to exactly the same size. and it should then be a multiple of the wall sizes, which means the floor tiles, which are designed to work with it, will probably fit better. So the first thing I might do is fit that piece in and have the floor fit within that. So what do we need to do for that? So the first thing I'm going to do is go and have a look back at the parts map. Just save all those. So this is the asset pack we're working with. We can see here I gathered some pieces together as a test. But what I didn't actually do was realize that this piece here, I think it says, yeah, this piece is actually a floor piece, not a ceiling piece, because I had all the ceiling pieces over here. So we should really have that over here, but it's also a specific floor piece that goes along the edge. So it's different to the others. It's the only piece that's a half a unit wide, and I think that makes up for the discrepancy between this point here and this point up here. But we can try that if I put this. Are we snapping? Yes, we are snapping. So if I take these pieces and move them out slightly, we can probably see if this is what's going to work. Oh, I must have moved it off grid at some point. Oh no, there you go. I think that's beneath the floor. Does that need a... Yeah, it's 25. Okay, there might be some juggling needed to get it to work, but oh, I seem to have built this beneath the grid. I'll just turn the grid off for a minute. Oh no, that's not the grid. Let's move it all up. Oops. Yeah, just so we can see everything a bit more clearly. Right, these pieces then would butt up against that. In questionable alignment. Not sure exactly where everything's supposed to be. Let's have a look. 20. Yeah, just make them align. I think this top of this backing piece is probably where it's supposed to align. Anyway, let's put those at 25 as well, just to show it. So in theory, is this right? Does that now align there as well? Yes. You can see it's matching better. So this piece is the same thickness at the top and bottom now. I think that's what we want to do. We want to add one of these pieces in. It kind of counts as a piece of the wall, so I'm going to probably put it in there as a wall piece. And we can add it into the same logic that places these other pieces. So I think we'll do that first. Yep. Let's do that. So that is floor CA. Yeah, it's called a floor piece, but which it is, but it's more about the wall. If we look at the demo map, we can see it in use. In fact, it's basically in front of every wall. There's this piece here. I think we probably would be best to conform to that. I think we're going to do that. Yeah, it's basically part of the wall segment. Right. Any questions? Not many viewers today. If you have any questions, drop them in the chat. I'll try to answer them. Right, where is our map? So this side piece, if we open up the procedure, again, we've got corners, we've got walls, rows, and each wall row is a lot of sections. Here we go, piece bottom, piece, and piece top. So I think this was, yeah, that's piece bottom, piece, and piece top. If I wanted to check, I can just quickly disconnect. Yeah, that's the bottom piece. That's the main piece, and then that's the top piece. So we've got to add another bottom piece. Now it's not, it's going to be, the alignment might be a bit fiddly. I need to look at that in a minute. I might turn the floor off for a second actually. Do that. Floor grid, right. We can see what's going on. So I'm gonna think, well, what's the logic for this bottom piece? I think it's placing it aligned to the back wall. we might need to use the thickness of this piece to determine where it comes, or we can work back from the actual thickness. It might be simpler to work back from the thickness of the top piece. We'll play with that in a minute. Let me get it working first. So in order to reference that piece, we're going to need, we've got these piece procedures. I'm going to add a new procedure for the floor. It's like a floor interfacing piece, just to make it line up nicely. So we'll call it that. That we need to resolve. We need to go and find the piece we're going to place. We'll come to that in a second, and we'll place it here. Nope, that's the bounds. I want the ID. I'll place it. Yeah, we get on with that. Right, so how do we refer to it? We've covered this a little bit before in the station resources. So this is a resource list for all of the pieces, and we've got the wall, bottom wall, top wall, main piece, and there's variants there. That's where we get the window variant. So under here we're going to add another resource. What happened there? Oh no, I added it in the wrong place. Let me remove that. I want to add it here. So we're going to call it wall interface, wall floor interface, and that was going to be a piece called floor CA. That's our piece. Default settings here should be fine. We need the identifier, so I'll copy that, and I think that's everything we need there. In the procedure, we can now paste in the descriptor so it knows how to get to that, and then it will be able to place something. So in the section, we're going to put the floor piece somewhere. I'm not sure where. Let's have a look. If I just did that, what do we end up with? I'm going to move these down. So, oh yeah, of course, it's filled the whole thing with the piece of floor. That's no good. What we could do, actually, is that going to work? Oh no, that's cut out by one. I think, right, it's being placed in the whole of the frame. I think we need to do the thing we did before and use the dimensions to resize it. So that splits it. I think we need to, it's the vertical we need to do. Let's take a copy of that and the Z and split it in the Z by that amount, place it there. That means we get it along the bottom. Now at the moment, actually you can't quite see it, let me remove the bottom piece. At the moment it's now stretched. Oh, it's actually the wrong way around. It's completely squashed because it's oriented that way. So we need to reorient in that space, so we'll do that as well. Let's do that. So frame operators, lots of them here. We need to reorient. Now reorient we talked about, which was basically keeping the world space the same, but changing the orientation within that. So it squishes and stretches it the other way. And so if we reorient in Z by 1, you should see it now. Looks more like it. Now we just stretched in the this direction slightly, and that'll be because we're not accounting for the actual wall piece that sits there. So there's probably different ways of doing that. We could look at the thickness of the wall piece. Maybe we should do that. We do that, and then shift this edge out by that amount. Yeah, we have this edge of the frame the right thickness. I think we set that up last week to match this top piece. So let's split this by the thickness of the bottom wall piece, and the remainder will be where we want this to occur. So we'll do that. Let us go and find that. So that was this bottom piece, which is here. So if we copy this, we'll get the information about it. We actually want the dimensions as well, so we might as well copy that. And this is the amount we want to inset by. So we'll do another split beforehand, which is going to be here. So if we split by, I don't know, let's do 0.5 in the X, yeah, in the X, it's now half a unit wide, which happens to be the actual size of it. What we actually want to do is the, let's guess the Y, nope. So this should then match the thickness of the floor, the bottom piece, which is I think that. What we're actually trying to do is build out from there, so the remainder, which is that bit, is what we want this to fit into. And in theory, that now if we put the bottom piece back in, it should fit nicely. It looks like it does, yes, there you go. So that is not too bad. And now our front line of our wall is the same at the top and the bottom. And as you can see, it's done it all the way around, of course. That looks much neater. Splendid. Now we have a much neater sort of C-section wall piece. Let's go back. Let's make sure we're all good. Okay, we've got all the 4 pieces now. That floor piece. Anything else we need to tidy up here? So we can make some notes in here. Build out from lower wall. Actual thickness, because we're building to that height, and then fix. So I'm tempted actually not to do the reorient here because I can show you another feature. So we saw before that it's actually the asset is oriented differently to the other pieces of wall. What we can do instead of just basically hard coding that information in here is if we go and look at the asset list again here, some of the options of things you can do. So here we've got descriptor referencing this asset, which we saw this piece here. Now there's an option to fix placement here, which if I turn it on, there's a few things we can change, and what I'm looking at doing is changing the orientation, which I think the best way to describe it is similar to the orient operator. It will rotate it within the space, within the bounds, without actually pointing it in a different direction. So if it can have the same effect. So if I do, I think, no, this is slightly different. So orientation is tipping it over in, if it's on its side, you can tip it upright and backwards and forwards, or you can turn it fully over. That's right. The rotation is the reorient in the Z, and so if I set that to 1, yeah, there you go. It fixes the fundamental orientation. So that's a more satisfying way of doing that because you're not hard coding it into the procedure, and it means if you wanted to change this to a different asset that maybe was correct or had a different problem, you could fix it up here, or an artist could do that. Or another reason is if there's variants here that you can switch between, and some are built differently, then you can fix them all up here, and it's not something you need to try and cope with in the procedures. This is more about fixing up the assets, hence the fixed placement. And that information lives in this mapping instead, rather than being part of the procedure. It keeps the procedure more general, I guess. That's probably a more satisfying fix for that particular issue. Okay. Now, the floor. We can build, now we've got a sort of more solid inner edge to the top and bottom. We can actually adjust the logic for the floor to be more satisfying. At the moment, where are we connecting it? Yeah, the floor is currently being built over the whole grid, the whole area. I can show you if I'll just show you quickly. What have we got? Utility, show frame. Yeah. So if I just quickly bung this in, you can see, well, there's the default input. There you go. So that's the bounds we're building to, this outer edge. And currently the floor is starting out here and coming in, which means it intersects at the bottom and isn't terribly satisfactory because we saw it didn't quite line up and it didn't fit the right hand side. What we can do instead is where we've got our wall 9 slice, which is this corner size, the center region is actually now within all of that. If I point at that, you can see it's there. So this is the region we want to build the floor within. So if we switch our floor grid to the center instead and look that up, that should give us much more satisfying results. So the lower edge, bottom corner here, is where it all starts. That now aligns with our new bottom edge. And because we are building to 4 meter sort of granularity because of the wall pieces, our 2 meter tiles now fit exactly. So we have a nice fit, and it means as we resize things, again, it always fits because we're always some multiple of walls, and that means we will also always be some multiple of the floor. And that looks much neater. Let's put the roof back in briefly. Oh, I've run out of things. Let me add another, whack another big one in down here for the floor and other things, and the ceiling as well. So the ceiling is hooked to the wrong bit. We need to do that to the center. There we go. So there we go. That's our much tidier default ceiling, floor, wall arrangement. Much tighter. Okay, cool. We've had 35 minutes of stream so far. That's a good point to have a quick reflect on what we've done and what we're going to do next. So this we've brought together these assets. We've built a resource list. We've referenced those assets. We've used their bounds to do calculations about where things are going. We've got the bounds that we're building to here, and then how that's divided up for placement. We've added editing handles so we can do some quick iteration on the layout of these rooms. Yeah, now we have our space station rooms. At the moment, obviously, it's fully interior stuff, but we'll explore more of that later. So these floor and ceiling, actually, what I might have a slight detour. This ceiling is something we're going to probably want to show and hide quite a lot, maybe, because it's easier to look from above when it's not on. So we could make it a parameter just for editing, and I might make the click, toggle it on and off instead of changing the seed. No, you can't click on it. Yeah, instead of changing the seed, I might get it to toggle the roof. Let's do that. So to make this a parameter, let's have a look at our main procedure again. This has bounds and seed, and that's it. And our roof is here. So what we need is this line to be conditional and dependent on an input parameter. So our conditional or geometry or content is this little one. If I hook that up, the default is false, so we don't get a roof. When it's on, we do. So if we bring it out as an input, like so, debug, let's call it. Let's call it ceiling because it's an internal thing. Right. And the default for that will be on. And I've just given it an extra name like a sort of category. Just to say it's for debugging, really, it's not really necessarily a feature. Maybe it's a feature. Let's leave it as a feature. Okay, we'll just call it ceiling. So on here, I can then turn it on and off independently now because it's a parameter for the instance. But I wanted to make it so we can click on it to change that. So what I will do in our editing logic, let's tidy these up a bit. Give them a note. This is the size in X, Y. I can move them around together. Again, these probably should be sub-procedures. That's something tidying up bit we can do in the future. Okay, so instead of changing the seed when we click, I want to set a bool parameter, and it's going to be not. I'll need to know the previous one, so current ceiling, and when we click, we're going to set it, and it's going to be the ceiling question mark parameter. But we don't want to set it to the same value. We want to set it to the opposite, and there is some logic operators, and we want not. So we're going to set it to not its current value, which will have the effect of toggling on and off. Give it a label. Double ceiling. Let's try that. Nope. Why is that not happy? Maybe I spelled it wrong. Let's have a look. Oh, I haven't looked that up. Yeah. So at the moment we're not feeding that input in. I'll zoom in a bit. Let's bring it over to make it easier to hook up. There you go. So we can toggle the ceiling on and off. Splendid. Move that. Actually, I might leave that there. I don't know what those are for. Okay, that was a little side track, but means it's easier to turn the ceiling on and off. You can just click the toggle thing here, but it means if you're smart editing, you can just click on it. You can still drag to move around. It does it independently. Let's do that. Okay. Okay, now the floor pieces. So this is something I was going to let me have a look on the website briefly. One of the projects we worked on before is this. So this is a game prototype called Maze that we did for Salix Games, and this I've just stopped the video here on this screenshot. So one of the features was procedural ornamental gardens, and this was something that we built in Apparance, and there's a combination of generated geometry for the ground, instance meshes for the plants, masking for all that as well, mixed materials, placing of larger and smaller objects, features and things like this, and the walls around it. And the approach I took for that was, it's a kind of, because it needs to be, there are patterns you need to have and regularity and symmetry and things like that in the layouts. I've got a nice video of this somewhere, but I'll dig out at some point. But things like features like this, where you want nice symmetry for it to be an aesthetically pleasing space, and that was the premise of how I approached this, and it built into quite a nice hierarchical system of deciding, given an area, a rectangle, deciding how to split that up and what to populate inside. And a lot of that was recursive in the sense that you might decide, okay, I'm going to split off two pieces along the side and I have a piece in the middle. And without thinking about any logic of what those things are. But what it would also do is the outside pieces would be reversed, so that would be symmetrical. Or were they mirrored? I think they might be mirrored. Or there was a flag that could go in to say, I want this one to be this way and this one to be mirrored, and I want them to use the same seeds, and that means that they would use this. They would generate the same content, and you'd end up with a mirrored sort of surround for your center area. And then the center area would do the same logic again. It would go, well, how am I going to split this up? Oh, I could split it the other way into 3. I could split it into 2. I could split it into a diamond with 4 triangular corners, and lots of and by adding a set of interesting ways to subdivide your space, and applying that recursively, and then when you get to a certain size, you just decide to, you say, okay, I'm actually going to be a pond, or I'm going to be some grass, or I'm going to be a flower bed, and then you do the content generation procedures, and you don't subdivide anymore. But that recursion of through a set of choices of what you could do produced some really nice results and lots of interesting variety as well. And it was something that could easily be added to. You think, oh, it'd be nice if things got split up in this particular way or that particular way, or I'm going to split it into 3, but there'll be walls between those sections. Lots of stuff like that. And that logic and that idea of recursion is something I wanted to try on the space station floor. One of the reasons is it's not particularly regular. If we go, let me save this and go back to the parts here. So if we look at these floor pieces here, these floor pieces, we can see that there are different sizes, and they do all fit together. They're on a kind of uniform unit grid. And I've talked a little bit about this before, but because they are different, it's not immediately obvious how you would just randomly apply them or add them to your floor to make it look interesting. And again, random is not necessarily the goal. We want patterns, and they can be randomly chosen, but there needs to be a sort of sensibility to this madness kind of approach. It can't just be completely chaotic. That generally tends not to look very nice. In some places it makes sense, in some places it doesn't. So what I was going to try and do is, using a similar idea of making choices about how to subdivide the space, and passing through seeds and maybe sort of mirroring stuff as well, I wanted to try and bring in some of that, so that we can use the different sized pieces. To go through a simple example, if we start with a large rectangle like the whole floor, you're going to need to make some sort of high level decisions. That could be something like, I'm going to inset 2 units from either side and then defer those 3 spaces to some sub procedures, or the same logic again. And maybe I'll pass down the same seeds to the sides so that they generate the same type of content, but I want it to be mirrored so that any offsetting is backwards or forwards, to be symmetrical. And what it would then go, the logic would go, okay, I've got my space is 2 units wide. I can't do much with that. I can't use any 4 wide pieces in that, so that limits my choices. But I can use the 2 wide pieces, or I can use the 1 wide pieces, or maybe there is a 2 wide piece that is long, but I'd have to have it a particular way around to be able to fit it in. And so depending on the size of the space you've got, if it restricts what you can do, you have to make some choices, and then you can only do certain things. But that means that you'll always be able to do something up down to the point where you decide you've got a single piece, and then you actually place it. It could be quite involved, but we can start quite simple, and I can illustrate some of these ideas. Another thing that this tile set, if you like, presents is these pieces at the bottom I mentioned before. These look like they're designed to form sort of like, what's the word I'm looking for? Borders, that's right. So you can build up, for example, pieces like this, and you can use that to perhaps surround an area. Oops, sorry. Obviously you can keep going. But the idea is that it's designed as a surround. Now, this we can embody. Well, this fits the sort of recursion and hierarchy logic quite well. One of the choices you could make when given an area is to say, okay, I'm going to inset a single unit all the way around, fill that with these pieces as a border, and then defer to the same logic, my filling logic again, which may or may not choose to do the same thing. You might get double border, or it will decide to do some other split or population operation. But that means you can actually incorporate these loops into the design, and it can do them. There'll be things it can't do. Obviously, you can only do what you build into it. But this approach is quite rich in that all the different choices. There's lots of choices and lots of layouts you can add, and the more you do, the more interesting the results. Yeah. So, question is, where do we start? First thing would be, I mean, this loop logic is quite good. And maybe that would be a good starting point to get things kicked off. It's a fairly straightforward step in the recursion system. We've already got the simple 2x2 tile filler. We can make judgments and logic about the space available. For example, if it's an even width and an even depth, we can use the 2x2 tiles just as a filler. If not, we have to do something else. It's all this sort of logic is kind of where I'm getting at. Yeah. Let's start with that and see how we get on. I mean, a simple decision would be to split a space in half. We could do that, or evenly into 3, or some margin, and all these values and parameters can be randomized as well. So like, how much am I going to split off either side? We'll do that. We can generate that, and an important part of this is the probability of different decisions. So if you've got something like the borders, you might not want that to happen as often as just filling a space in an interesting way, and so there might be like a 20% chance it would choose a border, assuming there's room and that sort of thing. So we can incorporate all that sort of logic in the Apparance procedures, and I think that's a good way to go. It's worth bearing in mind that the probably very similar logic will be used for the ceilings, but a different tile set. So we want to make a system that can work for both, and they have the similar sort of classification of pieces. We've got these 1x1s, which I will pull out here as well. I'm going to get rid of this. So this, we've got 1x1s. Oh, I deleted my corner. There. I mean, this piece probably could be used as a 1x1 without causing too much grief. We can include that. Move this up here. So we've got 1x1s on both sides, both up and lower. These I will consider separately. They can be special. We've got some 2x1s, which are present on both, here and here. That looks like a 4x1. Oh yeah, it's got underneath. It's got this same structure, I think. Look, oh, we'll see if it fits. I'm not sure if it will, but that looks like these ones. So if I move the 2x2 up, so there's those, and we've got 2x4, which matches here and here. And we can see a couple of things. There's no, how much is that? There's no 2x2 for the ceiling, and there's no 4x4 for the floor, but that's not a problem. What we do need to do though is make sure that the procedure can tell that there's no asset of a particular type, and we can do that in the logic as well. So we've got, what is it, 1, 2, 3, 4, 5, 6 different types. So we've got the 1x1, 2x1, 1x4, 2x2, 2x4, and 4x4. 6 different types. So if we set up a floor and a ceiling asset list for those 6 types, it's a bit fiddly to do. We'll start with just by adding a couple to start with. But in the resource list, when we're trying to look up the pieces, we can parameterize that by whether it's floor or ceiling, so that we can use the same procedures and we're just passing in a are you floor, are you ceiling parameter. And it will switch the asset set that we're referring to. And then for any one of those, we can work out whether or not there is a, it has particular ones. Some we can assume we know there always will be, like these two, we know there are. We don't have to put any logic in, but things like the 4x4 and the 2x2, we need to have some extra checks so it doesn't try and use them. So that's fine. What I will do then, what's a good place to start with this? Maybe the 1x1s. Let's make a 1x1 fill procedure like the 2x2, because that can be a default. Like, it can always play whatever size your space, it can always fill it with 1x1 tiles, and we'll just have it choose one and then use that. So that's a good sort of fallback when it can't finds it can't do anything else. Okay, I don't know. We're going to get the start. We'll start on this and we'll get a little bit done, and then we will probably call it a day. It just occurred to me that there's quite a few people at Gamescom. I wonder if that's why there's not many people watching. Anyway, let's carry on. I am going to add these 1x1s. So we need floor 1x1s, ceiling 1x1s. Let's see what that means in terms of the resources. So we've got floor here, floor 2x2. So we already started adding some of this stuff. It's grouped by, it's classified as floor. There's a floor 2x2. At the moment, that's a single mesh. But to generalize this, we probably want to make it into a variant, so that if, for example, we got some more assets or an artist to work on this, they could create a new piece and we could plug it in there, or maybe a different material or something. We'd have a different version. But in general, these pieces have multiple variants, and that's what we want to support. So I'll turn that into a variant. That will have broken the floor we've got. Let me just check what these are called. Floor CD, floor DG, floor DD, ceiling C. Don't know what those codes mean, but we can find out the single pieces ones fairly easily. I'm going to go and fix the 2x2 first in here. Yeah, so the floors stopped working. What we need to do is, so the reason that is because in the floor grid, floor piece, in here we are resolving variant 0, which is only applies when there's a single object. You set it to default 0. When it's a variant, it's indexed from 1. So variant number 1. What we need to use. There aren't any other variants, so there's no point choosing. We won't randomize this yet, but that should help. Yeah, that brings the floor back. Okay. So let's add in a source called floor 1x1. And that is going to be, let's just drag in that one, floor 1x1 there. The right one? No, that's a 2x1. Oops. Oh, they look bigger because they're, alright, floor 1x1. Oh, that was the straight one. Doesn't matter. Oh, sorry. That needs to be variance as well. So if we want to refer to this, it's called floor 1 by 1. I'm wondering whether we need the floor part, because it's already grouped under floor. So I might rename these so we don't have to parameterize it twice. I might just call these by their size. Again, that'll break the floor. We'll come back. We'll fix that now because it's looking for floor 2 by 2. There you go. So that's one of the 1 by 1s. I'll add in one of the other ones. D8. That one. No, this is the corner piece. What we want is CD, I think. Yep. Alright, and we can just drag these into here. And it will add it as another entry. And I can't remember which piece is which. Oh, that's the 2 by 2. I want that one. Yeah, let's have DD. Okay, that's floor 1 by 1. What we'll also need is ceiling and a 1 by 1. We can set to ceiling that piece. Is that a 1? Or make it a variant, and then we can add more. CD. What's the other one? That's the big one. I think. Was there only a couple ceiling ones? Can't remember. I'll do for now. So we can. That means we can parameterize by ceiling or floor and choose the 1 by 1s from the list of options. Let's get that working. So let's first. So is it worth generalizing this or not? Let me have a think. I think it might be. Sure. It's a fill. Let's make that general. Floor row, floor grid. Oh, that is the right place. So what we could do when we're digging through, at the moment we've hard coded the size here to 2. We don't necessarily want that. What we want to do be quite useful to be able to fill with any space, any size pieces. So let's do. Yeah, it's used here, isn't it? So let's do separate X and Y sizing. We can have that as a parameter coming in from the top. We could also have that as a parameter driven by the assets we've passed in. So let us, instead of doing the resolve here, what we can do is at the top level of floor grid, tell it what size we're working with. No, tell it what assets we're working with, and then it can work everything else out from there. So what I think we should do, if we look in here, so previously we used resolve, this resolve here, which is a singular resolve, descriptor in, ID of that asset out. Now, and you can point at different, you can find out how many variants there are and select one, but which is fine. But what there's a resolve variance here, which is actually quite a bit more powerful. And what you do is you give it your descriptor, and it will gather all of the variants into little structures, into a list of the ID and the bounds. So you get the same information, but except it's a list of that information for each one, and it means it's basically calling resolve multiple times for all of the different variants, and that means you've got a list to work with, which is fine. You don't, it's easier to have everything automatically work with from the list. So what we might do that, and I'm going to say we just pass in the descriptor and we use this list to do everything. So the first thing will be passing this list down so that when on the placement we can actually access that ID that needs placing. So I dig down in here. Here, instead of doing a resolve, what we're going to do is, there isn't an operator for extracting that information, but it's built such that the ID is the first thing in the list and the frame, the bounds, is the second thing in the list. So these are list accessors. We'll grab the so index 0 we'll get the ID. Let's just make a note of that. Set ID, and then like indexing into a structure, there's just two values in this particular case. Although, oh no, this is, hang on. So this is going to be the list, not a single one. For now, what we're going to do is just assume there's only one. We'll get the first item, and we'll extract from that. So we'll come back to improving that later. So this is where we would select randomly from the available assets. Now we've got one. There should always be a 0. Again, that's something to deal with later. And then we'll get the ID and the frame here. So we can feed that in. It's going to break, but that's fine. We don't need to resolve here. What we do need to do is pass this back up and into the recursion. So we're basically still passing it all down. The rows again, up here, assets, assets. And up here we now have an assets list which we can feed from there. It hasn't got anything because our floor grid hasn't got the descriptor set. What we can do now, if we go back to here, our floor one, let's get the 2x2 working again. Station floor 2x2. Sorry. Is that? Yeah. So now what we've done, we've parameterized by the full asset descriptor. And in theory, what that means is if we change this to 1x1, in theory, he says, we need to find out why that's not working. We've got something going on here. Oh, there's a couple of things. Oh, I know what it's done. Fine. These are individual pieces. It's just that they tile, and they're being stretched as well to 2x2 because we're not. You can see there's a 2x2. That's 2 units. Yeah, you can see the join here. There's 2x2 squares, and it's being scaled up. So let's try a different. We want something a bit more identifiable. Let me just change the. So where are we? Floor 1x1. DG, CD. No, I can't rearrange these. What I will do. Floor CD is that one. There you go. And I'll change that one to DG, which was that one. So the first entry 0 in that list is now a bit more obvious, so we can see what's going on. So it has switched to that asset. It's not using the size of the asset to do the fill. So let's do that next. How are we doing? Okay, we've just done just over an hour. I'll get some of this working and then we can stop. I don't mind doing a bit more. Right, floor piece. Nope. Where are we going? Floor grid, 4 rows. So the rows we want to use the asset sort of Y size because we're splitting in Y, and that'll be our dividing factor. So what we're going to do is pull this out here to be a parameter, and this is going to be the Y. Let's call it spacing, and At the moment, by default, that'll be 0, which is not great. So let's. Oh, we can't. We have to change that out here. Let's set that to 1 for a minute. And this 1.99. Oh, hang on. We also need to propagate it. This 1.99, instead of being hard coded, just needs to be slightly less than that value. So if I do. Let's do a subtract instead. So it's basically procedural. Okay. Right. We just want to check. Yeah, we're using mesh instancing. Okay, so that's better in that direction, but it's not based on the actual asset because we can see it's hard coded here. What I am going to do, in fact, I'll copy this. At this top level, if I pull out the first asset, is it can be any asset actually, because what we need to do is we don't need the ID, but what we do need is the bounds, and then we can do frame dimensions to get the sizing of everything. So if I feed the Y size in theory, that should be correct. And it means if we go up to the top level again, no, where are we going here? If I did the 2x2 again, that's now the right spacing because it's using the asset height. Doesn't work the other way, the X, but we'll do that next. So the X needs to come through as well. So let us find that. So here, so the rows we parameterized. We need to now do the columns in a row, which is what this is. So we're splitting in X. This is going in sideways. Again, we'll pull that out. That's now the X spacing. We need to do a subtract of a little bit, just because our logic works like that. Basically, make sure there's room for another piece before you carry on. Need to propagate it into the recursion, and then out here, this X spacing isn't a thing, so we'll bring that up here. You can actually rearrange those. So X, Y, and then at the top, we need to hook up the X. There we go. So now we can use single tiles, or if we go back to the top here, we can do the 2x2. Right. I might, just to illustrate that it's working, I might add in the 2x1s, I think. Do that. That might be good, and I think we might need to stop then. But we can look at, and then we can thoroughly dig into the patterns next week. But this is useful. Ceiling doesn't actually have anything. Oh, that was the other thing we're showing. Let's do that. Let's do that instead. So we'll go back to the floor 1x1. Now, in theory, what we want to be able to do in here is have the ceiling do the same, but the ceiling isn't working because it's not got a descriptor. So we can stick that in there, and it gets floor pieces. What we want to be able to do, well, actually, it will work. I don't know why I'm saying that. Ceiling, boink. Now I'll use ceiling pieces. Not very interesting, but it kind of works. Those look like floor pieces and those look like ceiling pieces. Maybe I've got them wrong around. Maybe not. Anyway, so at the moment this floor grid is a kind of utility that the patterning logic can use to just fill an area with a certain piece. And what we will do next week is, instead of starting with that, we will start with a general floor filler procedure, which is the sort of main entry point into filling a rectangular space with interesting floor. And that's where it'll go, how big am I, how much space have I got, make some decisions, apply some probabilities, choose how to split the space up, and then recurse into itself, using itself to fill those sub pieces, and until it gets down to a certain size, and then it'll say, okay, now I need to place some assets. And one of those options is to use the fill, like the 2x1 or the 2x2 or the 1x1, to fill that space. But there are other options that we've seen, like, oh, I've got a width of 2, I should use some of my 2 by something assets, that sort of thing. So let us, we'll do that next, we'll start on that next week. But what that's going to need is, we're not going to be specifying the full descriptor at the top. What we'll be specifying at the top is a partial descriptor. And probably what we want to be able to do is just say whether it's floor or not. I will create that now actually, let's do that. Where's floor? Oh, floor's in room. Let's start a new category. Floor filler procedure. Fill a angular floor area. And what I'm going to do there, for now, we're going to do just a floor grid, fill the area. But what we're going to do is, bear with me. So I'm just going to have a flag to say, are we doing ceiling or are we doing floor? That's going to be fine for now. And what that will do is select between 2 strings, floor or ceiling. And we can use that. There's a bunch of text operators I can show. We're doing various string stuff, and I'm going to build a little string like this. We go back to here. That's our full descriptor. What we're actually trying to do is replace this center part. So before we'll have station dot, and after we'll have, at the moment it's just with the 1 by 1, and that will be our descriptor. So you can build these procedurally basically. And what that means at this level, if I bring in the filler instead and use that, this is, so that was for the floor. If it's ceiling, it uses those pieces, and if it's floor, it uses those pieces. We can do the same for the down here, but this one is a ceiling. So now our filler knows it's the same. We can have the same logic, but it knows whether it's building a ceiling or a floor, and that's how it works. This grid, again, we might want to extract this resolution phase outwards, so that we're just passing in sets of assets. We'll talk about that next week, but that's a common paradigm as well that we can employ. So if I go back to the top, no, it's back to here, instead of a 2 by 2, that's a 1 by 1, I did a 2 by 2. Guess what's going to happen? So it's generated the floor using our 2 by 2 tiles, but there isn't one for the ceiling, so it doesn't do anything. That was what was expected. But anyway, everything's all nicely parameterized. I think it's time to call it a day there. And we'll have a quick look around. We have tidied up the edge here. We've got a better floor filling bit of logic. We've got some floor and ceiling differentiation. We've added in extra some of the 1 by 1 things. Yeah, we started setting the scene for more interesting floors and ceilings. I'm going to leave it there. So hopefully you enjoyed that. Join me next week, and I will same time, and we will start on the actual floor patterning and all the asset wrangling and all the logic and all the probability decisions and seed-based logic that's required to do that. Okay, take care. Talk to you again soon.